Good day everyone, welcome to my learning channel, Sir Fox Learning Channel. Today, we will learn Mathematics 8 with Teacher Arlene. At kung bago ka sa channel na ito, huwag mong kalimutang mag-subscribe at i-hit ang notification bell all para updated ka sa mga susunod ko pong videos. Happy learning!
Good day. Today, I'm going to present to you rational algebraic expressions. How to illustrate and simplify it. So, rational algebraic expressions are fractions that have polynomial in the numerator, denominator, or both. So, take a look at these examples. Examples of rational algebraic expressions are 3x over x minus 3. Next one, we have x minus 2 all over x plus 2. And another one, we have x squared plus 3x plus 1 all over 1, or simply x squared plus 3x plus 1. So how do we illustrate rational algebraic expression? To illustrate rational algebraic expression, we just write it in a fraction form. So let's take these examples. Okay, so let us illustrate the following rational algebraic expressions. Number 1, illustrate a rational expression whose numerator is r and denominator is s. So this one is very easy. So for us to illustrate rational algebraic expression, we say that we will just write it in fraction form. So here, rational expression whose numerator is r. So we have here r and denominator is s. Therefore, the answer is r over s. That's for number 1. So let's have the second example. The ratio of a number x and 4. So how are you going to illustrate this rational algebraic expression? The ratio of a number x and 4. So all we have to do is to write it in fraction form. Ratio of a number x and 4 can be written as x over 4. So there you have it, x over 4. Then number 3, given the expressions negative 3 and b plus 1, illustrate a rational algebraic expression whose numerator is negative 3. So again, this is very easy. So we have two expressions here, negative 3 and b plus 1. It is already given that the algebraic expression we need to illustrate must have a numerator of negative 3. So we have here negative 3 over the other expression, which is b plus 1. So, a rational algebraic expression whose numerator is negative 3 based on the given is negative 3 plus b, negative 3 I mean, over b plus 1. Okay, so that's how we illustrate rational algebraic expression. Very easy, right? This time, we will proceed with simplifying. How do we simplify rational algebraic expression? So, let me erase this and we will proceed with simplifying. Rational algebraic expression. Allow me to use the acronym RAE for rational algebraic expression. So how do we simplify rational algebraic expression? simplifying rational algebraic expression is the same with simplifying simple fraction. Remember, when you were in elementary, your teacher taught you how to simplify simple fraction. So let us recall that. Let us recall, how do we simplify simple fraction? We simplify 4 over 8. Okay, let us simplify 4 over 8. Now, to simplify this, all we have to do is to factor both numerator and denominator in such a way that there is common to both of them. So, 4 over 8 can be written as, the numerator, we have 4 times 1. And the denominator, 8, can be written as 4 times 2. So, as you can see, 4 is common to both numerator and denominator. So, for that, we can cancel 4. So, what's the reason why do we cancel 4 here? So, if we're going to cancel 4, we have here 1/2. So, again, why did we cancel 4? As you can see, 4 over 4 here is a fraction equivalent to 1. Okay, now the reason why we cancel it, because in effect, there's no effect. This 4 over 4 has no effect with 1/2. Because according to identity property of multiplication, any number multiplied to 1, the answer is the number itself. So if I have here 4 over 4, again, this is a fraction equivalent to 1. That is the reason why we cancel that. And since we cancel this will become 1. This is 1 times 1/2 will give you 1/2. Again, that's according to identity property of multiplication. So, we do not cancel without any reason. We cancel the common to both numerator and denominator because we have formed a fraction equivalent to 1. Okay? So, next, let us have 45 over 63. So, if we're going to factor 45, we have here 9 times 5. And our denominator, 63, we have 9 times 7. Again, there is common to both numerator and denominator. A fraction equivalent to 1, so we can cancel this. The answer will be 5 over 7. So, that's that easy. This time, we're going to put variables. So, we will be dealing with rational algebraic expression. So, you have recalled already how to simplify simple fraction. This time, let's go to rational algebraic expression. Let's take the example 3x to the 4th y cubed over 9x y squared. So, let us simplify this. So, remember that you have to consider factoring before simplifying rational algebraic expression, just like what we did in simple fraction. We're going to, again, factor both numerator and denominator here. So, I have here 3x to the 4th y cubed can be written as 3 times x times x times x times x. That's y x to the 4th. And we have y times y times y. That's the y cubed. Over 9 can be written as 3 times 3. Now we have here x and y squared, which is y times y. So after factoring both numerator and denominator, you can cancel now the common to both numerator and denominator that you will see. So we have here 3 in the numerator, 3 in the denominator. X, y, and y. So obviously, we have in our numerator x times x, which is x cubed. And of course, y over 3. So, when we simplify 3x to the 4th y cubed over 9x y squared, the result will be x cubed y over 3. Okay, so let's have another example. Let's take x squared minus 16 all over x minus 4. Let us simplify this. Okay, during the previous discussion, we have discussed how to factor polynomials, right? So as you can see, our numerator is a difference of two squares. So if we're going to factor this, we will just get the square root of the first term, square root of the last term or the second term, we have 4. One is sum and the other is difference. Okay, that's how we factor difference of two squares. And in our denominator, we have x minus 4. Now, notice that the quantity x minus 4 is common to both numerator and denominator, so we can cancel this. The answer will be x plus 4. Okay? So, that's how we simplify. So, let's have another example. Let's take this. 3x plus 6 all over x plus 2. Okay, so we're going to factor numerator using the common monomial factor. Remember, so 3x here can be written as 3 times x, and this 6. Okay, we have here 3 times x, and this 6 can be written as 3 times 2. So obviously, the common monomial factor here is 3. So let's take out 3 and put the other factor or the remaining factor, the non-common factor, inside the grouping symbol x plus 2 here. All over x plus 2. Again, obviously, x plus 2 is common, so we're going to cancel it because that's a fraction equivalent to 1. Now, we have 3 as the final answer. So, let's have more examples for you to understand it better. Okay? Let's have 2 more examples. This time, I'm going to erase this. Okay? Okay. So, let's take the 4th example. We have x squared plus 5x plus 6 over, or all over, x squared minus 4. So, let us simplify this. Again, we have to factor both numerator and denominator. And we're going to see if there's common. So, we can simplify. So, in our numerator, we have the general quadratic trinomial. If you can still remember how to factor it, we're looking for 2 binomials, diba? The factors of general quadratic trinomial. So, how do you factor? The first term of each factor will be x. And then, we're looking for 2 numbers whose whose product is 6 and whose sum is 5. So, what are those numbers? That if you're going to multiply, will give you 6, and if you will add, 5. Okay, we have 3, positive 3, and positive 2. So, let's check. 3 times 2 will give us 6. But if you're going to add 3 plus 2, that is 5. Okay, therefore, the factors of x squared plus 5x plus 6 are the 2 binomials x plus 3 and x plus 2. Okay, our denominator, obviously, difference of 2 squares again. So, the factors will be sum and difference of 2 terms. Get the square root of the first term, x. Square root of the last term or second term, it's 2. So, we have here, the quantity x plus 2 are common. We can cancel. Finally, the answer will be x plus 3 all over x minus 2. Okay, I hope you can follow. So, let's have the last example. Factor the irrational expression, simplify the rational expression x squared minus 81 all over 2x plus 18. So, how are we going to simplify this? Of course, again, we're going to factor both numerator and denominator. Let us factor the numerator, which is a difference of 2 squares. So again, the factor of difference of two squares are the sum and difference of two terms. We will get the square root of the first term, x, and the square root of the second term, that's 9. And in the numerator, okay, we're going to factor this by getting the common monomial factor. Okay, take a look at this. This 2x can be written as 2 times x, and this 18 can be written as 2 times 9. So obviously, the common monomial factor is 2. But we're going to take out 2 and write inside the grouping symbol the non-common factor. That is x here plus 9. Again, the quantity x plus 9 is common to both numerator and denominator. So we can cancel it because that is a fraction equivalent to 1. So in our numerator, we have x minus 9, and in the denominator, we have 2. Okay, we have simplified it. Okay, that's how we simplify rational algebraic expression. Very easy, right? Just don't forget what we discussed before about factoring, because you will be using that in simplifying rational algebraic expression. Okay, thank you.